Lesson 53, power rule for exponents and conversion as a volume. So power rule is really a fun little thing that we're going to do here, but before we get to the power rule, let's review some of the other rules that we have learned so far. The first one is if you have a number multiplied by itself a number of times, then, let me get a pencil here, sorry, then you just take whatever the base number is times the number of times you multiply it together. For example, if you have n times n times n, it would be n to the third. Or if I had 2 times 2 times 2 times 2, it would be 2 to the fourth. So that's what the first rule says. The next one says if you have x to the n power times x to the n power, if the bases are the same and you're multiplying, see how the bases are the same? That's telling us that means when we multiply them together, we're going to add our exponents together because there's m x's and n x's, so altogether you're going to have m plus n x's. And to put some numbers to that to make a little bit more sense is if you have n to the third times n to the fourth, you're going to get n to the seventh. You add your exponents. So basically you would have this, and then that would be 3, and then 1, 2, 3, 4, and that would go back up to rule number 1, where you would count them. There's 7, it would be n to the 7th. So when the bases are the same, you simply add your exponents so that you don't have to write them all out, because if you had really big numbers, that would be really hard. Okay, some really simple ones. If you have anything to the first power, it's just the number itself. So if I have 2 to the first power, you just get 2, because you multiply it by itself. Just one time. 1 times 2 times nothing. Okay, now this one, if you have x to the negative n power, it's the same as writing it in the denominator. So if I had like 3 to the negative 2 power, it's the same as 1 over 3 squared. It becomes positive, so it'd be 1/9. Anything to the 0 power is just 1. So no matter how big it is, if we have mn, x, y, p, q to the 0 power, it's just going to be 1. All right, one more property before we get into the power rule is if I'm dividing, if I have x to the m divided by x to the n, we subtract our exponents. If you want it to be on the numerator, you subtract the bottom from the top. If you want it to be in the denominator, you subtract the numerator exponent from the denominator exponent. And to make sense of this with numbers, we have x to the 5th over x squared. If we want it in the numerator, we take 5 minus 2, and we get x to the third. If you want it in the denominator, then you take the denominator exponent minus the numerator exponent, and we get x to the negative 3. Or you can get this answer and then just move it down to the denominator. All right, the power rule is one of my favorite rules. If you have x to the m power raised to the nth power, see how it's a power to a power? If you have a power to a power, then you just multiply it together, and you get x to the mn. So it's kind of like saying if I have x squared cubed, it's the same thing as saying x squared times x squared times x squared, and then we would add our exponents and get x to the 6th. Or you could just multiply them together and get x to the 6th. So if you have a power to a power, we just multiply exponents. If they're one a power on top of the other, you multiply. On the other hand, if you have, see how these are level? You would add them. If it's a base to an exponent times the same base to a different exponent, you just add your exponents. All right, let's go and do a couple examples. They start out super easy. So we have a power. Do you recognize this? It's a power. An exponent's called a power to another power, so we just multiply, so we get a to the 10th. A power to a power, so we multiply, so we get x to the 8th. A power to a power, we get xm to the negative 8. And you can even have variables. This is a k, so it'd be m to the 2k. Just remember to put your coefficient in front of your variables, because k2 doesn't really make too much sense. All right, let's try them. Now those were super simple, easy. They get harder though, of course, as everything seems to get harder, right? Let's try a couple more of these. All right, now here's the problem with these. You have numbers now. So you do not, this is what everyone's going to do, they're going to try multiplying the number. This is the same thing as 3 to the negative 2. If you think of the number as having like a little 1 exponent on there, you multiply your exponent times your exponent, so you get 3 to the negative 2, which is not going to be 6. It's going to be 1 over 9. Now let's just multiply our other exponents. So we get x to the 4th, y to the negative 10, all over, and we have to take it times this, and this 1. I already have that. And we're also going to multiply it times these two exponents as well. So it's going to be z to the negative 8. Now, in these examples, it says, it doesn't tell you if you have to put all your answers in the numerator or denominator. You can just leave them as they are, unless they say make all your exponents positive, make all your exponents negative, etc. But what you do have to do is see this 3 to the negative 2. You can't leave it like that. It's going to go in the denominator. So you're going to get x to the 4th, y to the negative 10, over, this would be 3 squared, z to the negative 8. And even this isn't done. We're going to say x to the 4th, y to the negative 10, all over 9z to the negative 8. So you do have to multiply your number out. You're raising it to a power, so it would be 3 times 3, not 6. Be very careful on those. All right, I squeezed myself in here. Made this kind of hard. So let's start with this one. We're going to do the same thing. We're going to distribute. Remember, there's a 1 right here on a number. You do not take 2 times negative 5. That's the trickiest part about these, I think. You're going to take it that times that, that times that, that times that, and that times that. So we're going to get 2 to the negative 5, a to the 10th, b to the negative 10, z to the 50th. You cannot keep a number to a negative power, so we're going to put it in the denominator. So we're going to get a to the 10th, b to the negative 10th, z to the 50, all over 2 times 2 times 2 times 2 times 2, which is going to be 32. If we put this in the bottom, this is going to be 2 to the 5th in the bottom, which is 32. You can't raise a number to a negative power, so you have to move it into the denominator. All right, last one. This one's a little bit easier, I think. There's actually more examples in your book. I don't think I did them all. All right, so here we go again. We're going to get 4. Is it going to be 8 or is it going to be 16? 4 squared, x. Now these have 1s. If there's nothing there, it's going to have a 1. So it's going to be x squared, y squared, over m to the negative 4th power. And then you just need to clean it up. So it's going to be 16x squared, y squared, over m to the negative 4. All right, next. Not wasting a lot of time today. Why don't you try this one yourself and see if you can get the answer. All right, hopefully you paused the video and started it. So we're going to get 3 cubed. So it's going to be x to the 0 if we distribute this through, right? Distribute it through. And that's going to be y to the 3rd all over k to the 12th. This is going to be 1. So you can cross it out because when you multiply anything by 1, you just get what's left. So 3 to the 3rd power is 3 times 3 is 9 times 3 is 27. Y to the 3rd all over k to the 12th. So hopefully that's not so hard. The hardest part, like what I said, is you have to be careful you don't put 9. It's 3 to the 3rd power. Think of a little 1 right here. So you're multiplying exponents, you don't multiply the exponent times the base. All right, we're shifting gears, unit multipliers. Some of you really hate unit multipliers. I think unit multipliers are quite fun. So this one says use 3 unit multipliers. Maybe this will be the time that you get it. And you want to convert 180 cubic feet, which looks like this, to cubic inches. Now our unit multiplier for this is 12 inches is 1 foot. So get your unit multiplier hanging out somewhere. You want 3 of them, so right away you write down the first number and then you write your 3 unit multipliers. 1, 2, and a 3. So do you see how there's 3 feet here? The feet times feet times feet. You need to have a feet times a feet times a feet, like that. And then you're going to do your units. You need as many since there's 3. This is the same thing as feet times feet times feet, like that. That's the same thing as cubed. So we have 12 inches is 1 foot. 12 inches is 1 foot. And 12 inches is 1 foot again. So you have your feet and a feet and a feet and a feet, or a foot and a foot. So all your feet cross out, so you're left with 180 times 12 times 12 times 12 inches cubed, and you can multiply that out or just leave it like that. The book tends to leave it just like that. So the only thing different is it's cubed this time, so you need 3 unit multipliers to go with each cube. All right, let's crank it up a little bit here. Use 6 unit multipliers to convert cubic feet to cubic. I guess we have to have a number here. 800 cubic feet to convert 800 cubic centimeters. So forgot the number there. All right, so how do you write that? It's 800 centimeters cubed to feet. Now, if you're going from centimeters to feet, you need to stop at inches. So you need inches to be in the middle. So we know that there's 1 inch is equal to 2.54 centimeters. And then we're going to go from inches to feet, right? So we're going to need, there's 12 inches. Let's go the other way around. 1 foot and 12 inches. Now you can rewrite these either way. You can write 2.54 centimeters per 1 inch. And you can also write 12 inches in 1 foot. You have to pick which one you want to use when you do these problems. So here we go. We need 6. I'm going to have to write small. 1, 2, 3, 4, 5, 6. I got them all in. All right, so first thing we're going to go from inches. So our goal here is we're going to go from centimeters. We're going to go in from centimeters to inches to feet. First thing you have to change it from metric to our English system. So we're going to do centimeters. So we need 3 of them. So we're going to do a centimeter, and a centimeter. We know that there's 2.54 centimeters. 2.54 centimeters in, whoops, I wrote on top of that, 1 inch. 1 inch, 1 inch. Now all the centimeters, there's 3 of them, cross out with these 3 centimeters. Now we go the same way. Since the inches are on top, you want your inches to be on the bottom. You always want to go diagonal. Since your centimeters here were on the top, you need to put them on the bottom. So that's how you pick. You want to pick the one with the inches on the bottom. So that's why you pick that one. So we have 1 foot is 12 inches. 1 foot is 12 inches. Whoops. And one more time, we're almost done. 1 foot is 12 inches. So we have our inches, our inches, our inches, cross out with our inches and our inches and our inches. And so you just write your answer like this. 800 times, well, there's nothing on the top but 1, so we don't need to write those all down. But we're going to have feet cubed because we have a foot and a foot and a foot. And that's all over. You can just write it like this. 2.54, since there's 3 of them, you can just say cubed times 12 cubed. Or you can write them all out. Whatever makes you happiest there. All right, so extra credit is it's Monday night. And I didn't have an extra credit for the other video, but the extra credit for this is it is not Monday night. The extra credit is it is Sunday night and I'm doing math videos. All right, that's it for lesson 53.